OpenAI Assistants. Currently in beta, this API is designed to help developers build assistants capable of performing a variety of tasks. It's quite simple. We create the assistants, give them instructions or system messages, and a list of tools that they can use. Then, you simply have a conversation with them. In this example, we will use the assistants from the beta package and use create to set up the assistant. And we only need to use this function once because it will end up being saved on platform.openai.com/assistants as shown. After creating the assistant, we can talk to it using its unique ID. However, currently there's no mechanism to control the number of assistants with the same name. So if you run the create function again, a new assistant with the same name will be created. Therefore, let's use list to display the list of assistants, and then we take the ID if we find an assistant named Socrates, for example, and if not, we end up creating it. Now, instead of managing the context ourselves and saving it, we hand this task over to OpenAI, which permanently saves the context. This is amazing, but it may not be suitable for all use cases, especially those that require privacy, such as customer support services or e-governance cases where personal data may be processed. Here we create the memory using something called threads.create. Simply put, each chat session or user will need a separate thread. Alright, let's send a message to Socrates using threads.messages.create. Here we need the thread ID and, as usual, the role of the message, which will be user in this case. We submit it and take a look at how the context is managed with threads. And now we will start a run process with our thread to send the prompts. Every run is an interaction with the model, and a run can consist of a single message or multiple messages, as well as images when it's supported, and so on. Once a run is triggered, the interaction is placed in a queue, and we need to check the status of this interaction before trying to extract a response. In other words, you won't get an instant response like the traditional chat completions class. To use run, we need the thread ID for the context and the ID of the assistant itself. And to check the status of the interaction and get a response, we do the following. We use a while loop to check the state of the interaction from in progress until we get a completed message and extract a response. Now, as you can see, we can get the response and have a conversation using threads instead of managing the list or the database ourselves. You can also check out the chatbot files in the GitHub repo for a more interactive example using Socrates.